Alright, on page 2 you are doing more factoring, so just make sure again that every single time you are checking for a GCF. On this one, when you see that negative out in front, you want to factor out a negative or a -1. When you factor that out, that's basically going to change the sign in front of all three of these. So now instead of this being a negative, it's positive. Instead of this being positive, it's negative. Instead of this being positive, it is negative. Now go from here. Carry your negative or your -1 down. This is a trinomial, so it's going to factor into two binomials. Put your two sets of parentheses there. And then think to yourself, what times what gives me x squared? Put your x in the front of both. What are factors of 56 that when I add or subtract them, in this case it's going to be subtract because you want this to be negative, will give you this -1. So you can use 8 and 7 will give you a -1. You want more negatives, so put the negative with the 8. So that when you're outside 7x and you're inside -8x combined together, it gives you the -1. Foil it back together to check your work, and then that should give you this. Distribute this negative through to check to make sure you got back to the original problem. On number 12, you can, again, need to think about GCF. You can factor a 2 out of all three of these terms. You can also factor out an x out of all three of these terms. So the 2x goes out front. If it helps you to write divided by 2x or fraction bar 2x underneath all of these to help you know what goes in here, then do that. Okay? When you divide each of these terms by 2x, you are left with this. Okay, and then you're on a trinomial. That factors into two binomials. Put down your two sets of parentheses. X times x gives you x squared, so put x's in the front. Factors of 52, that can give you a 17. 4 times 13 will give you 52. Since everything here is positive, both of your binomials are going to be positive. Foil it back together to get this. Distribute that back through to check to see that you got that. On number 13, the only GCF of these is just an x. Factor that x out. Again, you're dividing all three terms by x to see what's left in this trinomial. Trinomials will factor down into two binomials. Put your two sets of parentheses. X times x gives you x squared. Put an x in front of both. 1 times 2, this is prime, is the only thing that gives you a 2, so put those in the back of both. Your outside is now 1x, your inside is 2x. Combined together, or combining like terms, that gives you 3x, so we are good. Number 14 is only a binomial. When you get to a binomial, either it is going to be the dots, the difference of two squares, or, like in this case, it is just going to have a GCF. So 8 and 6 can both be divided by 2. X squared and x can both be divided by x. Factor that out to the front. If you, again, want to put divided by 2x under both of these terms, that may help you know what is left in the parentheses. Okay, and then you can distribute that back through to check your work. 15. Oh no, there's something out in front of the x squared, but luckily it can be factored out. There is a GCF of 6. Dividing all three terms by 6 leaves you this in the trinomial. Trinomials factor into two binomials. Put your two sets of parentheses down. Has to be x in the front of both. And then factors of 4 that can add or subtract, in this case add, together to give you a 4 would be 2 and 2, and they're both going to have to be minus or negative. Okay, and then you can write your answer in a more simplified version like this, but this answer is fine. 16, GCF. Not only is there a 7, but you can also take out an x squared. So divide both terms by 7x squared. You are left with x squared minus 4. Be careful, be careful, be careful. This is one of those instances where a binomial might be the difference of two squares. So when these terms are both perfect squares and there is a minus in the middle, you can factor that down into these two binomials, the x plus 2 and the x minus 2. 17 is just that difference of two squares. So that one should be simple by now. Square root of x squared is x, put that in the front of both. Square root of 49 is 7. Put that in the back of both. Put one as a positive, one as a negative, or one as a sum and one as a difference. That's that sum and difference pattern. Number 18. This is our first one where you have a number out in front of the x squared. So your choices to go in front are 1 times 4 or 2 times 2, and then you put the x behind those. So on this one, it's kind of one of those where you have to guess and check. Luckily, 5 is prime, so your only choices of factors for 5 would be 1 and 5. So you just have to get everything in the right place so that when you FOIL it back together, you get this. And that's what's frustrating for you. It's just a guess and check on that. Number 19, we are now solving. Notice that everything is on the left. There's an equal 0 on the right. To solve these, you just set each factor equal to 0. So this would be x equals -1 and x equals 2. To check these, if you plug -1 into here, you get 0. 0 times anything is 0. If you plug a 2 in to both of these x's, this one is going to be a 0, and 0 times anything again is 0. So you can go back and check these. Number 20, first do the GCF, which is a 2x. Factor that out. You're left with a binomial. This binomial is not a difference of perfect squares or a difference of 2 squares, so you do not need to factor it any further. Still need to solve. So again, everything is on the left. There's an equal 0. So this factor will be set equal to 0. This factor is set equal to 0, and solve both. So you have x equals 0 on this one, and x equals 5 divided by 4 on that one. Last two on this page. On number 21, you can factor out a 9 first. If you forgot to factor out the 9, you might notice that you got the same answers in the end. When you are solving, that will happen. However, you did not factor completely. So you should factor out a 9 first. This one, be careful, don't stop here. This is the difference of 2 squares, so it can factor down into that sum and difference pattern, and then you solve each of the factors. This 9, if you divided this whole side by 9, it would cancel that 9. If you divided the 0 by 9, it would still be 0. So that's where the 9 went. It didn't just disappear. We divided the 9 away, and it canceled over here, and 0 divided by 9 is still 0 over here. Okay, and last one on this page, factor this first. There is not a GCF, so just put an x in the front of both binomials. Find the factors of 10. That will add together to give you -3. Since you want more negatives in the middle, make the 5 negative and the 2 positive. Everything is on the left equals 0, so set both factors equal to 0 and solve. And that is it for that page.